Okay, so here's part C. We're looking at this sequence here. A fifth plus a sixth plus a seventh plus an eighth. And we're just trying to see, is that bigger than a half?
Well, an eighth is 1/4 of a half. And all of these are bigger than an eighth. So this should be bigger than a half.
Okay.
Yeah. It's 4/8 is a half.
Ah. 4/8 is a half.
And that's bigger than 4/8.
Why?
Because these are bigger than 1/8.
Interesting. So we could say this is bigger than a half.
Yes.
This is actually exactly equal to a half.
And
This box
bigger.
is bigger than a half.
that box is bigger than a half.
What about this box here? That's going to be a 9 plus all the way up to plus 1/16.
Yeah, this is also bigger than a half.
Because 1/16 is...
It's an eighth of a half, and all the rest of the numbers are bigger than 1/16.
And how many numbers do you have?
Well, it's 9 to 16, so you have
to
7. You have 7 numbers. Well, no, 8 numbers.
Why 8?
Because you have to include the 9. If you subtract 8 from both, 9 to 16 is 1 to 8.
Interesting. So we have 8 numbers here. All of them except 1/16 are bigger than 1/16. But 8/16 is a half.
and
It's bigger than a half.
So this box is bigger than a half. What about this box? 1/17 plus 1/18 plus up to 1/32.
It's the same thing.
it's going to be bigger than a half.
Okay, can you explain it?
Because 1/32 is a 16th of a half. If you subtract 16 from it all, you get your 16 numbers in it. And all of the other numbers are bigger than 1/16. So that means it's bigger than a half.
Okay, what about the next bucket?
Well, it'll still be bigger than a half for exactly the same reasons.
Okay, what is the next bucket?
It's 1/33 to 1/64.
Huh.
So that means if all these boxes are getting bigger than a half,
And you have infinitely many of them.
so you're going to get to infinity.
Aha. So this is an interesting argument.
Yeah.
Because not only does it show us how to group the numbers so that we're always bigger than a half, it actually helps us see how far out we need to go to get bigger. Remember I said we need to get bigger than 100,
Yeah.
for example? Let's see if we could get bigger than 100. Well, how many of these boxes would we need since they're all a little bit bigger than a half?
Well, you need around 200.
We'd need around 200 of these boxes. And the first box is 2 to the 0, the second box is 2 to the 1, the third box is 2 squared, 2 cubed, 2 to the 4th,
2 to the 5th.
2 to the 5th. So we're going to get let's see, 1, 2, 3, 4, 5. The sixth box is 2 to the 5th.
Yeah.
So did I say that right?
Yeah, this is 2 to the 5th.
2 to the 5th. So where is the 200th box going to end?
Well, it'll end on 2 to the 200. Because, well, this is the one. It'll end on 2 to the 199.
So 2 to the 199. Whenever I get to that one, 1 over 2 to the 199,
It's a pretty small number.
I'll be bigger than, the sum will be bigger than 200.
Wow.
Right. And let's see, I do have my calculator with me, so we can calculate, we can see what 2 to the 199th is. Let's see. Sorry about that, probably should have my calculator out first. Alright. So
Scientific
2
mode.
to the 199 is 8 times 10 to the 59. So 8 with 59 zeros
Wow.
at the end of it.
Ouch.
That's a big number.
Yeah.
So you have to go out pretty far, but
It works.
it works. At that point, we know for sure from our argument that we'll be bigger than 200. Now we might be bigger than 200 before that. We don't know because we're just approximating here, and we're always a little bit low, except on this one. We're always a little bit low. So maybe we get there first, but we know for sure at 8.03 times 10 to the 59th, we're there.
Yeah.
And for any number, I could figure out when we're going to get there.
Cool.
Pretty amazing, right?
Yeah.
Yep.
All right, so let's talk about a few more things.
Okay.